I forgot that there's a cowbell over here, guys. All we need is more cowbell. That's the only thing we need. Alright guys, so my homie Ed is going to talk about beacons, and so nearby triggers. That's I guess the title. Okay, so let's do some clapping. Let's give a round of applause to Ed and take it away.
Thank you. So I'm working on a service that we've been building internally for a few months now, actually. And one of the issues that we came up against was forming groups. So people use this app and they want to be able to form these ad hoc groups quickly and be able to leave the groups and stuff. But forming the groups was kind of a challenge we looked at and said, well, there's lots of traditional ways to do it. We could create a code and we could share the code and we could people text it and then everyone's going to sit there with their phones, kind of share that information. We thought about QR codes, but then cameras aren't always that reliable if it's dark or you don't really have the right position. Everybody's going to get the camera set up. So I thought, well, let's just think about it for a while. Maybe we'll come up with another way to do it. And I've spent a lot of time working with beacons, iBeacons. How many people here have ever played around with the iBeacon stuff from Apple? Okay. Sorry?
Very early on.
Yeah. So it was an iOS 7 technology, kind of got a lot of hype in the early days, and it's kind of petered out, but it's still a very valid technology and kind of has lots of interesting applications if you can just kind of think outside the box a little bit. So I tried to use that concept in approaching this problem of how do we kind of trigger these nearby events so that if I wanted to be able to connect with somebody else, I might be able to use a beacon technology to do something with that. So I was going to explain sort of how we did that. So the concept is that if you've got two phones, one of them can act as a broadcaster. So you don't need a hardware beacon in order to actually generate an iBeacon. The phones can create virtual beacons just in software and create that signal or whatever that another phone can listen for. And you get the same sort of capabilities and features like ranging on those beacons. So one of the things beacons can do, you can do from the iPhone at least, is range for a beacon. So if you know what you're looking for, you can range for it. You can kind of get a general gist of about how far away it is. Apple provides 3 tiers. There's far, sort of nearby, and immediate. And immediate's generally within about a foot or so of the other device beacon, so you can be right there. And you also get an unknown indeterminate value as well. iBeacon, the spec is basically made up of 3 different components. One is a UUID, which is that long character string, a major number, and a minor number. And those are 16-bit unsigned integers that can help identify one beacon from another that's within the same UUID set. When you listen for beacons, you can listen for any kind of scale on it. You can say, I want to look for just the UUID. I want to find any beacon that's got that UUID on it, and I can get a response from the OS, when it sees one. And then you can read the major and minor codes and maybe do something with that. Or you can narrow it down. If you want to look for a very specific beacon, you can go all the way down to looking for the UUID major and minor. So the idea behind this concept of using beacons to do this sort of sharing idea was to have the broadcaster generate a virtual beacon, broadcast out on its UUID, and it generates a unique 32-bit code. So a random number generator that basically combines that into the major and minor and spreads that out on the network. You take that code and save it up on a database, maybe Firebase. Then you store whatever relevant info you want with that code. Generate the virtual beacon, and then listen. Just broadcast. And whenever you're done, you got to make sure you tear that back down so you can stop the broadcast and then delete the data off the database. So everything's cleaned up. Now somebody who wants to join, somebody who wants to connect in, can just do the standard iOS, hey, I'm going to listen for beacons, I'm going to go range them, I'm going to see when I can find anybody nearby. So it just generates the standard code you can find anywhere on generating listeners. Looks for the UUID in general, so just the broad UUID. I don't care about the major minor. When I find one, I want to make sure that it's immediate proximity, so that it's right nearby. I'm not accidentally picking up on somebody else who might be using the same technology. When you find it, grab the major minor, go read it up in the database, pull that information down, and if everything's good, you can stop listening, and you've got all your info. So in practice, I've got a couple charts on how that code looks. So this is sort of the broadcaster approach, where Peripheral Manager is part of the core Bluetooth tech, CB Peripheral Manager. You can create one pretty easily. Create yourself as a delegate, put all the information, put yourself on the just a global queue to get informed on when things happen in your for the Peripheral Manager. Create a random number. Unfortunately, they're unsigned ints, 16, so all the flip-flop and Swift to convert 32s back to 16s and so on. But you end up with a major-minor combo. And then I create a CL beacon region that's part of the core location tech for creating regions, beacon regions, with my proximity UUID. So this is just something you define with that long 64-character string. Choose whatever you want, just try not to collide with somebody else. And then set the major and minor in there. And then some identifiers, so in case you really want to kind of check up on what the identifier was. Our tech is DX technology that we're putting together, so I just created a name for that. And then you have to generate this peripheral data object. And that's pretty simply done by using the beacon region. There's a call in the OS for creating this peripheral data with some level of measured power. You can set that all the way from, I think, minus 128 to 127. It's a 8-bit signed int. But if you pass a nil in, it takes some sort of system default. I don't think Apple specifies what that is, but I guess it depends on the device, and it kind of sets a general level out for you. So every example I've ever seen sticks it as nil. I played around with it for a while, tried different values and stuff. It didn't seem to make much difference, so I just left it as nil. Seems to work just fine. You're going to get back, let's see. Okay, I want to make sure I've still got my Peripheral Manager. So this is sort of pseudocode. This is actual real code, but you kind of have to place it in the right places in your actual classes to make it all run right. But let's see, what else do we got? That's it. So now you just want to turn your Peripheral Manager and start advertising your data. And that creates a virtual beacon. Your phone will now just signal out there. Anybody who's listening can go here for it. And when you're happy and done, just make sure you tear it back down, delete your key, and everything's cleaned up. So that's the broadcaster side. On the listener side, this is somewhat standard iOS code for doing beacon ranging. You create your co-location manager, set yourself as a delegate, make sure you go do all the authorization, whether you're iOS whatever version, you got to jump all through all those hoops to make sure you've got core location turned on and authorized. And then you create a similar beacon region, but notice in this case I didn't specify the major and minor. So I don't care what they are, I just want to listen for anything that's got my shared proximity UID and start ranging for those beacons. And I'll get callbacks every second or so from the operating system. Whenever it's looking for stuff and it sees the beacons, I'm going to get this callback. Location Manager did range beacons. I'll get an array of beacons, CL beacons, and then I'm just going to go deconstruct them. So right now, all I really care about are ones that are in the immediate range. So I'm just going to take that array of beacons, flatten it out to only find ones that have the proximity of immediate, and then turn that into my string that I'm going to look up back in my database. So that's the same string code that I created on the broadcaster side. If I found one, I'm going to go load that from the data from the database, and then I'm happy with that. I can stop my ranging and say, hey, everything's good to go. Okay, before I get into a demo, let's see if that actually works. I got a live demo, knock on wood, fingers crossed. Afraid of the demo gods, it's going to work, but any questions on the coding part? Yeah?
Are you able to run it in the simulator, or you just have to use like devices?
No, devices. Yeah, that'd be nice, but... Anything else? Okay, let's go give this a try. So I'm going to dump the mic.
That's cool.
Okay, so here's our app. It's kind of a garden mapping app that lets you find, locate things, look at the various data that's up there. It's kind of still a work in progress, but the main thing I'm going to demonstrate here is the actual people kind of grouping opportunities. So here's my list of people. Right now my group is just me. There's nobody else in it. So I'd like to add somebody else to the group. Now, we implemented a couple different ways to do that, but this is the tapping sort of way. So right now, I've just generated my beacon. So this is the broadcaster app. It's listening for anybody, basically, to come nearby. So I'm going to put him far enough away. And disconnect him.
Need some help?
I think I'm good. We should be able to see this next. Yes. Okay. Same app. We're on a different phone. Again, we're going to go to our people. In this case, I want to join. So now I'm scanning. I'm looking for the beacon, and since there's nothing's in close immediate proximity, nothing's happening. And fingers crossed, we get close enough, and so the tech works. It's not that hard to integrate. I can envision all kinds of use cases for it, whether it's check-ins that you're coming to an event and something you just want to check people in quickly. Anytime you want to form ad hoc and groupings of things, it seems a really quick and easy way to do it.
Wow.
So,
Awesome.
okay, yeah, questions?
Yeah, it seems like, I mean, this technology's been around a while. It feels like this hasn't gotten widely adopted. Because like applications like this seem like the kind of thing you would think about, but I feel like you don't see them very much. Do you have thoughts on why that is, or?
Yeah, and I think that a lot of people just look at what the beacons are and they see the traditional use cases. Oh, I'm going to go look at a museum, or I'm going to get my seat at my ballpark and stuff, and don't really start experimenting, thinking maybe outside the box. What else can I do with this tech? And I've kind of been playing around with the tech long enough. I think I've sort of searched for these other use cases. So maybe it's just a lack of imagination.
Yeah.
Yeah.
What's the range? Is it about 100 feet for the beacon?
It depends on the device. We've gotten about 200 feet on some hardware beacons. I haven't tested the iPhone beacon generator, but just to see the signal now, it's kind of loose. At that point, you probably have to have line of sight. You can maybe get about 150 feet. But typically, they say 30 meters is about as far as you'll want to go.
So, and when you're running your iPhone as a broadcaster,
Mm-hmm.
what kind of how long? If you just turn it on, do nothing but run this, how long before your battery's dead?
Well, let's see.
I mean, is it a low power?
Yeah, it's not too bad. I mean, it pings. It's not something that just constantly is on, like you're talking on the phone, or we're doing Wi-Fi. It basically turns on, pings, and then turns off. So there is this issue with Bluetooth that I found. If you're not listening within the window of the ping, you're going to miss some. So if you've got an array of beacons out there and you're just sort of listening for them and you're watching them, you'll see them drop in and out as you miss in the ping windows. But so don't rely on the fact that you'll get it every single time. Yeah.
I think maybe the lack of adoption may be due to privacy concerns. People are leery of turning on promiscuous mode, so to speak, and then they think, oh, I'll be getting slammed with all these ads, or somebody just send me a lot of coupons. I'll walk past the store and they'll send me beacons. So maybe that's one of the things that's holding this back, maybe.
That might be what Eddistone's about.
Yeah.
Eddystone, for those who don't know, that's Google's version of this. They took the whole beacon concept and added a URL on top of it, so that if you ever hear a beacon, it's supposed to trigger off your phone to say, oh, let me go look up some data on the internet for you, to show your advertisement or whatever.
And then what about background modes? Like, for example, your app. Is there a use case that can be implemented in low enough energy or whatever, where the app is on somebody's phone that if you happen to walk past them, it would be like, oh, hey, it could be broadcasting all the time, or something along those lines?
I think you probably could be broadcasting. We're doing some other beacon tech, another project I'm working on called Gaggle, where we're constantly listening, and our goal is all day life on this app, at least 8 hours or so, at least of lifetime on your phone. and it runs in the background, so totally unobtrusive. Once you've turned it on, it just works.
Oh wow. So
Because I know the listening, you can use the core location,
Mhm.
you know, like DIN or beacon region kind of thing, but
Yeah.
I didn't know if you could do the sort of a similar thing with broadcasting.
Yeah, we didn't do the enter region. The main issue with that is that you don't always get the exit events. You know, you might miss it and stuff. So we need to be absolutely certain. This is an application we call Gaggle. It's meant to keep kids or groups together so that they don't wander off. If you missed an exit event, that would be horrible. So
Right.
we're constantly ranging.
So, what you did in the demo right now, so you have the app running in the foreground or background?
Both of those were foreground. I probably could have run the other one, at least the broadcaster in the background without a problem.
Uh-huh.
The joining one, I think you just want to keep that in the foreground since you're trying to check. But if you just wanted these ad hoc ones as you're moving around, it probably can run the background.
So that's interesting because you know most of the iOS apps, once you get background, that's pretty much it. So you can run a lot of stuff in the background, but what sounds like you can run like sort of broadcasting in the background, regardless of whatever app you're implementing.
Yeah.
Okay, interesting.
How are you not getting shut down? I mean, how is the app not getting?
Well, there's a couple of techniques we've used to do background stuff. So you not only get the background time, but if you set the background event to re-trigger yourself on the background, there's a hack you can do to try to keep yourself running continuously, not continuously, but periodically, so you never really totally die.
Or you can run audio file in the background.
Well,
You know
yeah.
what that happened.
Right. I thought they discouraged the background task triggering background tasks.
They do discourage it, but if there's application users that really make use, I mean, Facebook abused it
Yeah.
and got caught. But if you're trying to keep kids together and you want your app to run in the background and to alert you when somebody separates, I think that's a fair and legitimate use case for that kind of scenario. Yeah.
How does this compare with multi-peer connectivity, and does this use that?
I've done some of the peering stuff, and that's also very flaky. You'll see the peers kind of come in and out. Setting those up seemed, at least when I was doing it about a year or so ago, seemed very unreliable. It was
Okay.
not a stable connection. Yeah.
Yeah, so I had been using multi-peer connectivity recently also, and with that you can set it up so that every user is both broadcasting and listening. Is that
Right.
something you can do with this?
Yeah, in theory you could. I mean, you probably would then want to separate out maybe use your major for so you don't see yourself constantly. So I don't think there's any other way to filter. Well, I guess if you knew what you're broadcasting on, you could, when you receive it, just discard it. So yeah, you could certainly do both. Okay, well, I hope I've opened some imagination now. It sounds like we got a lot of maybe ideas brewing out there, but that's my talk for today.
Cool.
Yeah.